The expression here can be written in this form, and it asks us to show that p equals 12 and find the value of the integer q. Then, hence, find this integral, and also hence find the exact value of the same integral between 1 and 2. So I've written out the question in summary form here. So let's just use Pascal's triangle. It's the power 3, so it's the 1, 3, 3, 1 row. But we've got a 2 here, haven't we? So we've got to be careful here. So part A then, it's 2 plus x squared cubed. Now Pascal's, here it is here, 1, 3, 3, 1. The first term here just descends in powers, 2 cubed, 2 squared, 2 to the 1. And the x squared descends in powers, but from the other direction. Cubed, x squared, squared, x squared. So then we just combine these. So this is 8, is our first term. Then 3 fours are 12, so it's 12x squared. Then we've got 3 times 2 is 6 times an x to the 4, 6x to the 4. And then the last term is x to the power 6. Okay, so that's what we've done then. So we used Pascal's triangle there and just wrote down all the constituent parts. So we've got the answer there. So here p equals 12, which we've shown there, and q is equal to the value 6, isn't it? Now part 2, find this integral. So b, let's call that I. So I is equal to, it's the integral here cubed, which we can write as this. So it's 8 plus 12x squared plus 6x to the 4 plus x to the 6, all divided by x to the 4, isn't it? dx, so that's equal to the integral. So the first term will be 8x to the minus 4 plus 12, and 2 of those will cancel to leave 12, and bring the x squared that's left up to the top, plus 6. And then the last term is plus an x squared, isn't it? dx. So the 6, because the x to the 4 is cancelled when we split the fraction up, and the last term, there's just an x squared left on top. So this is the integral then. So let's do that and turn our attention to this problem now. So this is equal to 8x, increase the power by 1, divide by that number, plus 12, increase the power by 1, divide by that number, plus 6x, plus, because we constants integrate to constant times x, plus increase the power, divide by the number, plus a k. Let's tidy it up. So we've got minus 8/3 over 3x cubed, minus 12 over x, plus 6x, plus x cubed over 3, plus a k at the end, which we can squeeze in there. So there's the answer then. So part 2 now, we need to evaluate this integral between the bounds of 2 and 1. So let's do that. So the answer is equal to, this integral is minus 8 over 3x cubed minus 12 over x plus 6x plus x cubed over 3 between 1 and 2, isn't it? Those are our bounds for the definite integral. So let's turn our attention to this problem now and work out this solution here. So here we get top value take bottom value. The top value put a 2 in. So it's minus 8, 2 cubed will be 8 to cancel with it. So we're just left with minus 1/3. This is our top value. Take away the bottom value. So the first one was a 2 in. The 2 cubed cancelled with the 8 to leave minus 1/3. Then the 2 goes in here. 12 over 2 is 6 with a minus. Then we've got a 2 in here. 6 2s are 12. And then we've got 2 cubed rather, which is 8 over 3. So there's those terms. Then put the 1 in, minus 8 over 3 here. Minus 12 over 1 is minus 12. Plus 6 times 1 is 6, and then it's plus a third. So what have we got then? We've got minus a third, plus 8 thirds, and then plus 1 more third. So this is minus 7 thirds plus 7 thirds, minus 1 third is plus 6 thirds. So I'll leave it as 6 thirds for the moment, because that's these terms here, here, and here done. Then we've got a 6, which we can have, this is a 6 here, and then we've got a minus 6. So there's the 6, and we've got minus 6 here, but that becomes a plus 6, that makes 12. And then we're just left with this 8 thirds, which we should have also included, shouldn't we? Plus 8 thirds. So we've got 14 thirds plus 12. 12 plus 14 thirds, which is 4 and 2 thirds. So the answer is 16 and 2 thirds for the integral unit squared, because it's a measure of area.